All right, welcome. How you doing? Nice to see you again. This week we are continuing on with our quest to build a roguelike style game called LambdaTrek. It's based off of an old game called Star Trek or later Super Trek, and its many variants and clones. If this is your first time tuning in, welcome. Nice to see you. And this is kind of what the game looks like. I'm just going to fire up another terminal because it's a terminal-based application for the moment. And we're using this cool TUI library in Haskell called Brick, which is doing wonders for us for rendering our UI and such. It's pretty nice. If I go over my project directory like so, and I run my stack program, exec, LambdaTrek, like so, we get this lovely screen. We have an info panel on the right. We have our sector view on the left here. It's like a region of space that the game's like zoomed in on. We have our command input here. Raise our shields. And then we have this little dialogue area here. So everything that happens kind of in world in the game. We have like different roles around the bridge that tell you what's going on. Pretty cool. So last week, I believe we just got torpedoes working. And I guess we're going to continue on with that. If we have them mostly working enough, then I think there might be a few small things to work on to tidy up, and then we might want... Oh, yeah, we might want to implement like our ship blowing up. I don't think we have that done yet. I think that'll be enough gameplay mechanics if we can start looking at simulating more of the quadrant and like different sectors and stuff like that. And then world generation at some point, and startup and all that stuff. So yeah, we're getting there. We're starting to move along pretty quickly now. We're starting to get to a bit of a clip where we can implement things pretty fast, which is nice. So let's get to the code. I'll fire up a good old operating system, Emacs, and this is our Batir. So implemented adding the torpedo count to the info panel, decrement the torpedo count when fired, we destroy an enemy on hit. Okay. I think the only thing I want to change about torpedoes is just give them a small percentage chance to miss. Just a small one. And then otherwise, I think this is pretty good. So let's go do that now. Source, LambdaTrek. We're going to go into the simulation. Sorry, not state. Simulation, and we're going to combat. Okay, firing torpedo. Okay, so that's right here. Line 122. We just destroy the enemy outright. So instead we can, we're in a state here, so we can get our RNG out. Oh, what did I call it? Random gen. That's what I called it. Random gen. Okay, and now to use our random gen, we have some helper functions. Let's get a random percent. Chance. Chance should be our range. I think we have a random range function. Yeah. I'll just do like 0 to 100. And then we could just do here, if chance is less than or equal to 3, like a 3% chance, then do just enemy, else destroy the enemy. Oh, right, sorry, that doesn't give back just this, it gives back a tuple of the RNG's next state. Oh, what's the problem here? Oh, it's got to be in state. Okay, no problem. Sorry, my bad. Which is good because we would have to put the RNG prime out and put that back in state. And that makes sense that I wrote that. So instead of a let binding, we're going to do a binding here. 0, 100. And then we can just let bind the damaged enemy. If chance is less than or equal to 3, then enemy. Else destroy the enemy. Yeah, so there's always a small chance that we might get a miss. Then we should probably tie the dialogue to that as well while we're here. We also want to do it here. Yeah, if it's less than or equal to our magic number 3, then say dialogue, combat, torpedo, missed. We'll make this a better message. I think we should probably add the coordinate. Maybe, or at least the intended coordinate, and then else. Probably don't need the parentheses around that. Pop, pop, pop. Instead of having this equation twice, we can probably give it a name. Is hit. Oh, let's flip that around to make that make sense. So if is hit is greater than or equal to 3. And then we flip these around. Same here. Okay, yeah, it's alright. So if we have a hit, then we do this dialogue, otherwise do this dialogue, and the damage enemy. If it's a hit, then we destroy the enemy, otherwise leave the enemy alone. And then update the enemy ships. Although, I think this is going to be a bit of a... That should probably not work. Let's fire up a builder. We're on the test runner, and we'll do the fast mode with the file watcher on. Not file, fast. Bang. Well, unless enemy is the expected. Oh no, it's fine. Yeah, that should pass. Yeah. Okay. For some reason I was thinking destroy enemy, return to this tuple, but no, we constructed, so it's fine. Okay, good. Super. Alright, that's probably pretty good. Let's commit that. Add small chance for torpedo to miss. Let's do the, let's update the text on that one. Bring that over here. Let's get the coordinate of that particular one. It's in coord. I will have to pack that. Okay, yeah, and then we need to get rid of the binding of RNG here. And that should be good. Super. Looking clean, looking good, looking nice. Love it. Let's commit that. Fix up combat miss dialogue. Torpedo. %3 chance torpedo will miss the enemy. Okay, there we go. Okay, so far our enemies, they just shoot back with phasers. They don't really use torpedoes. It's probably okay. What else do we have here? Alright, we got shield up. Shield up. Alright, we can move. Took a little damage. Shield strength still at 73%. Still energy. We can't fire with our phasers through our shields, I believe. Yeah, shields are up, Captain. We must first lower the shields in order to fire the phasers. Shields are holding. We took some more damage while working on this. We can fire our torpedoes through those shields, though. All right, we'll fire one torpedo at 8-3. We destroyed the ship. Cool. Torpedoes down to 4. Our hull is at 3. Let's dock with the station. Okay, we're resupplied. We're good. All right, let's implement game over for hull destroyed. So far, so good with this, and then I think we'll move on to adding more sectors and being able to jump to different ones. The good old warp command. Okie doke. So let's go over to the simulation. Top level, update simulation. Okay, so if we get the command result performed, enter game state. Oh, where do we handle game over? So I believe we already implemented that for... did we implement any of that yet? Maybe we haven't. No. Oh, we did. Yep. Game over screen. That's right. Check for game over. That's the function. Okay, it's in our top level app module. All right. So game over has a couple more things. If the ship energy is less than or equals 0, then we get the game over screen. We have, or the ship hull is like less than or equal to 0. We haven't fully built yet. There we go. Oh, we got just right taken out. Oh. Is there a world where they can't hit us for less than 10? Or did I just introduce a bug? Oh, that's fine. I guess they're just walloping us with a lot of damage. Probably give ourselves more hull here. Yeah, let's go do that quickly, just so we can see this work. I think in the initial game state, we set up the ship with 10 hull. Let's make it 30, let's say. It's probably better. Yeah, we got 30 hull. Now let's move in. Alright, we're in some combat. We're taking some damage. Whoosh, things are happening. We'll fire a torpedo at the wrong coordinate. 8-4. Oh, it missed. Okay, cool. Game over. Okie doke. So that's good. Game over when hell drops to less than 0. Runs out. Super duper. Okay, so that means we should probably think about how we're going to represent many sectors, not just one. Okay, currently in our game state, we have just the one sector represented here. It's kind of like the current sector. And that's where we do a lot of our work on. And now we need more than one sector. And then we need a way to change sectors, which is through the warp command. So we need, let's see, game state sectors. Some kind of container for all of our sectors. Although, no, I'm not going to get into the optimization or structuring data that way. I was thinking like we could probably just put all the sector data in one destructive arrays style record. It might actually work. I don't know what that would look like. So, let's just play around a little bit with that idea and see where that leads. Let's just call it like quadrant. Although I'm probably getting the terminology flipped around if you're as Chucky. Okay, so if you don't know what the struct of arrays pattern is, it comes as a concept. It's not, I don't think it's unique to C, but like it's where I heard of it first, or I learned about it first. The idea is that when you have a bunch of entities that are all alike in structure, like sectors, or, I don't know, enemies. The instinct for a programmer is to define what one of those things, the structure of one of those things is, like a sector. So, for example, in our simulation, we have the sector module, right? And it gives us all the fields for a single sector, all the stars in that sector, the enemy ships in that sector, the stations available in that sector. But we don't have just one sector, right? We have lots of sectors. And we could have a container that like has each individual sector structure in it, arrayed out, and then we index into that container and pull out the sector we want, right? And we index into that container to grab the sector. And the reason why I think it comes up, I probably heard about it in C first, is that this is not terribly efficient as a memory layout pattern, which we're not usually super careful about in Haskell, although we can be if we want to be. And anywho, the idea is that where you have one, you probably have many. And so instead of creating a generic container to fit sectors in, because you'll lose, at least in C, maybe in Haskell too, you'll lose some memory and some space, and therefore some efficiency to padding, in order to fit those structs into those arrays or into that memory. So an alternative to that in C land is the struct of arrays. So instead of having a sector, you have one struct that contains all of the sectors, and each field that you would normally have in a sector is now an array of that data for all the sectors. So in our quadrant, for example, right, this would be like an array int of int for the stars. Although each sector is going to have many stars. Anyways, and the other thing would be like the quadrant enemy ships. So you might not want an array here, but maybe you do. Anyways, the enemy ships would be same thing there. Enemy. The quadrant stations. This might not work really for sectors, but I hope you get the general gist of the idea. This probably works better for a more flat structure, like ships. Yeah, it would work better for this structure since they're all like just plain like ints and stuff. All right, so you can be like data enemies, well, enemies, and instead of enemy position X would be enemy positions X, and this would be like your array int of int, so on and so forth through all the record fields. And that way, if you need a particular enemy, you just grab the index And then you have a function that looks into this record for each field, indexes out, looks up all the data for that one particular enemy, constructs the enemy, and then passes that back to you. For quadrants and like this, because we already, the sector itself is also a container for many ships and many stations and many stars. I'm thinking we'll probably want like a map for that, which is almost like an array, but we'll have like, we'll hash in the coordinate of the sector in order to get a array of data that we need. So each of these will have buckets. That could be a good way of doing this. So let's look at package. We have containers. No, we just have array there. Okay, so let's add containers so we can get maps. Or like hash maps if we want. Yeah, I'm gonna stash this. I'm just kind of experimenting with this, so I want to make sure that I can throw it away, but I want to be able to do it in multiple steps. So what I think I'm going to do is I'm going to stash this and create a branch, a temporary branch. Yeah. And we'll call it quadrant. There we go. Quadrant branch. Okay, let's reapply that. Okay. So we'll import data.map. And qualified. And this will be a map. Be a map. We'll keep it the same as the sector right now. Just so hopefully we don't have to update too much of that handling code. This will be a map as well. And a station. Alright, we're gonna need well, to do it in this module. Alright, so let's pull this out into a quadrant module. LambdaTrek simulation dot quadrant. Pop that there. We're gonna need quite a few mods. We're gonna data dot array. We're gonna need data dot map. Get rid of that up there. We're gonna need some imports from simulation. Enemy and station. Okay, and we can hopefully derive some base classes for ourselves. Okay. Cool. So now that we have this quadrant structure, I'm just using ints here to reference the different sectors. Well, the game command. Let's look at the game command. So, in a typical game of Trek, our map is many let's see, many sectors composed together. I think we get like move to quadrant 3-7. We can make ours map whatever size we want, really. So this is the Super Trek version. It's a little bit more involved than I want to get for our game. Let's see, I just want a description of the typical map. I think it's like 9x9-ish, something like that. Hello. 8x8. Okay, so they call what I'm calling a sector, they call a quadrant. So I did get the terminator filter, but whatever. This is LambdaTrek, not Star Trek. So yeah, the commands are given, I guess, in numeric integers. So we can do them as pairs as well. This is reusing a map. That should be fine. And then we're going to need sector. And then we're going to get the sector from the quadrant. We have a... We'll call it get sector. Yeah, you give it an int key. Let's do a quadrant. And then you get, maybe, sector. It would be super dope if we didn't have this maybe here. But we don't have statically known maps here. So the Haskell can't figure out if this is a valid key in the map before, like, statically. So there's a chance it might not be in the map, basically. And so we have to return maybe. This could possibly make our code somewhat annoying to deal with. Because we know as we're developing this game that the quadrant is like every sector is going to be available. Like there's no such thing as missing in the map for us. So we can maybe use some of the unsafe map API for this. Which is in data map. We have unsafe indexing, I think. Yeah, so this would be like the unsafe lookup. And I think that's fine if we return an error there. That would be like error as in like an IO error, because this should never happen, because we know that the map's going to be perfectly constructed every time. The other option is we could define our own, where we do know the size and importance of define our own function, but I think this will work just well. Just as well. So, in order to implement this function, we get our quadrant and the coordinate. Maybe the sector coordinate. And we got to return a sector. So we could return a sector. Let's do it like that. We can pull out each element we need to build the sector. And we got the quadrant stars with, we're going to import that operator. And vector coord. Sector ship enemies. With the sector coord and stations. And then we can construct the sector with those things. Except the names will probably be taken already. Just get rid of that, and I guess stations. There we go. We need to enable record wildcards for that. By the way, chat, if you have any questions, of course, always just pop in there. Let me know what you're thinking. Let me know what you want to know. Quadrant stars. Could a magic expect to type array int int. E. Is that just behind a little bit? Oh, I probably just got the arguments flipped around, didn't I? Map. And key comes second. Yeah. That should be right. Let's see, type of stars. This is just E. Is that cause, oh, is that because data array? Okay, sorry. Data array also implements this operator. import that from map. That's better. Many ships. There. We got some shadow binding warnings. That's kind of annoying. A little bit of ticks on them. And that should be that. Good and compiling, nice and green. Happy, happy. Okay, so we can get a sector from a quadrant. So that's good. And we want to be able to... What do we need to do? We need to also update the sector and the quadrant. It's just sort of like maps modify. Except we're going to be modifying each of these maps. Alright, so we're going to update a sector. We're going to take a quadrant and a coordinate for that sector, and the new sector. I'll return a new quadrant. So we're not going to use record wildcards here because quadrant appears on the left-hand side of the rightmost arrow, which leads, as we discovered in many previous streams, is kind of annoying to deal with. Sector coordinate, new sector. So then, sector, however, doesn't have this problem actually, so we don't need to find new sector. We can use record wildcards here to get the different elements out if we're going to be doing it anyway. And we're going to return a quadrant. Where each of these things are updated. Such that quadrant stars is equal to something. Enemy ships. And quadrant stations is equal to something here. And I think basically we want the update function here, or the modify, alter, just. We do update now. Yeah, okay. We'll go with adjust, update the value at a specific key with the result of the provided function, which will be just const our value, new value basically. So we're going to import that qualified. Import it as m. Will be m dot what was alter, adjust, and that gives the function, which will just be const sector stars of the ooh, yeah, we're gonna make the map itself, which is gonna be quadrant stars of quadrant. Oh, what am I missing here? Oh, the key. The key is gonna be sector chord. Like that. I think that'll compile. And we're on to the next one, which is gonna be very, very similar. But instead of sector stars, it's gonna be sector ships, enemies. Oh, what is it? Sector enemy ships. Thank you, GHCID, my friend. Okay, quadrant stations. Similar thing again. A set of sector stars. We're gonna have sector stations. Okay, so that compiles and updates the sector there. Let's see. Okay, so now we can update things, we can get a sector. I think the next move here is to change our game state so that we have the current coordinate in as like a top level variable here. So instead of sector, right, this will just be a coordinate. And then we introduce the quadrant here. And then we have to update all the code that talks to about the sector and updates the sector, and using our new update function to like put that data into the quadrant. Phew. Okay, so if this API is pretty decent, then hopefully this will be a fairly small change. But what I really like about Haskell is that this is like super refactorable. So let's make this a sector coordinate. And the game state quadrant. The quadrant. So this is gonna like totally blow up for a little bit, and that's fine. Get back to green as quickly as we can. Okay, so we will cut this. We'll make this 0, 0. Our little test sector is the 0, 0 sector. Okay, then we need to initialize our quadrant map. So we need an init quadrant function in order to do that. Let's call it init quadrant. sector star map. And we're going to do M from list. Okay, and then from each in here, we put our tuples for our sectors. So for now, we have 0, 0, and that takes a list of stars, which we initially set to just this list 10, 10, which is fine. And then we need our sector ship map, enemy ship map. It's going to be m dot from list, in similar fashion, as well as our sector station map. It's also going to be m dot from list. All right, feeling very structive arrays. Okay, once we have those filled in, we have a quadrant. And I don't know how many times I'm going to mistype enemy on this stream. It's the worst. So we need our, I think we have an enemies array there, as well as maybe for stations. Oh no, maybe we just set it up manually in state as well. No, in sector. Yes, we did. So we'll just copy that. Oh yeah, we didn't. We should also implement enemy patrolling. Oh well, we'll get to that next. This would be kind of neat if the enemies weren't just like static, like they can move around on their turn if they're in the patrolling state and they're not in combat. Okay, and then we just have one more hole, which is our sector map, which we'll copy this one as well. And then what do we got? Okay, and then a bunch of other errors in other modules. Okay, so that should be fine. My editor's server just hasn't caught up to me yet. So in UI now, all right, we render the sector, the current sector. So now we just have to change this sector display here to get the sector, because gain state sector now refers to a coordinate, right? It doesn't refer to the sector data structure. So this will just be we're going to need to import quadrant for that. Okay, and quadrant, get sector from quadrant, use the quadrant first. Which we get from game state quadrant. And then we pass in sector coordinates. All kinds of type errors. Let's see, what do we got? Okay, yes. So we have to namespace all this stuff. That's going to be game quadrant. What is this one? This is a weird one. No match. Expect to type quadrant with actual type game state in the first argument of get sector. We might need to put parentheses around you. It's just an operator precedence issue. Okay, so that should be the sector again. And now, let's see. So combat. Yep. Wide-reaching effects. Type check isn't caught up with it quite yet there. Let's see, it is in 114. Right, so enemy at coordinate in sector now. Sector isn't there, okay. Okay, yeah, this is gonna have to change a little bit here. Okay, so sector here. It's more like sector coordinate. Might want to rename that field. And then sector. And we need the coordinate quadrant. We can use maybe current sector. Quadrant. Of course, a current sector. And then we gotta pull in get sector into scope. Okay, so now we have the sector. So the rest of this code, good work, except for updating the current sector. So we're going to zoom in on this game state quadrant. No. No, we don't need to zoom in on the quadrant itself. We just need to set it. so this is going to become... and then this... This is going to become... Maybe we can zoom in on the quadrant and do this. So the quadrant ships become... well, we'll need the lenses for quadrants, so we'll go do that. Okay. Make fields. I'll need template Haskell for that. I will need to import lens.micro.th. I'll just cut that temporarily and put a hole there. Let's see, we get no instance, has enemy ships, or has use of enemy ships. Go to quadrants. So something demands the origin sense. Okay, so that should be there. Okay, so it should... Many ships should be it, except we're probably going to do the namespacing thing that we've been doing, which I don't like. I don't have much of a choice. Which is to put this qualified with everything else. I'm going to give it a shorter name. It was pretty unique. Ooh, okay, that's interesting. So not doing the fields thing where it's like, I don't want to have to do it this way. Gross. No, I want it to just be enemy ships. Spelled a quadrant. It's done by convention. I'm just trying to remember if make fields does it with like an underscore in order to get the short name out, like the constructor name prefix. And I'm just doing it by like looking up examples of where I did it properly. Yeah, I did it right for enemy sector. Just enemy ships. You don't have to write sector enemy ships. It's just, yeah, it should mirror. Maybe I need those as well. Okay. Back to quadrant. Let's add those in. Oh, it sure as hell should. Export that. Why isn't it exporting enemy ships? Come on. Some lens libraries want you to like prefix with this. No, that's definitely not this one. Okay, what am I doing wrong? Let's look at the docs. Okay. Did I mistype something then? Quadrant. Enemy ships. God, what? Oh, come on. Ah, that's so annoying. Okay, can I execute a quadrant? This should be the enemy ships array. So now we can't match the type cubic quadrant with this function. 0 to defunctor identity. Expected a setter. What we got? So this isn't the lens. This is the literal function from the record. Which is why I want that. It says it doesn't export it. What if I just do this like the library says? Is it the placement of this in the file? Is that what's doing it? Oh, we need this to work. Okay, if it's not generating the right classes, that might be why. There's a way to check what template Haskell splices are being generated. I don't always remember how to do it. Oh, it's a GHC option, like dedump splices or something. Yeah, the dedump splices flag. Okay, so could do that. Okay, we'll try that in a second. Let's just try maybe make lenses. This is the one where you got to put the underscore first, for sure, for sure. This. Yeah, those need to be updated. And these ones. Bang, bang, bang. And that one as well. That one as well. And this one. It's still not exporting the damn freaking thing. Why not? What is it? That hole and this one up here. Okay. Let's fix this one here. This one is pretty straightforward. We need the quadrant first. Hopefully that lens thing fixed that annoying issue. That's super annoying. I don't know what's going on there. Game state quadrant. And current sector. And then rate of binding per sector. That's going to be get sector. Quadrant. Current sector. Oh, we got another one and do fire. Oh, good times, good times. That's gonna also do updating stuff. Okay, let's do this one first. Okay, so here we have our whole, it's gonna be our map, int, array, whatever. Array of enemies. So I think we can just return what we had before. Where we have enemies here. All right, okay. We need the map function there. So that's going to be adjust. Here and enemies bound here. That's a function. And then it just needs a key, which is our current coordinate, current sector coordinate. And the map. Okay, we're going to need to import that, data.map. Qualified, of course. I feel like we're going to need some helper functions to work with state and stuff like that. It's getting... we have some common patterns kind of emerging here. And I don't like importing implementation details. We don't need to. Okay, this one's going to follow a similar pattern. So we do the fire here. We're getting the enemy ships again. And we're map the results. So what we're going to have to do is we're going to have to get the current sector. And we're going to have to get the quadrant. Yeah. And then we have to zoom in on the game state. Actually, I don't think we need to put the quadrant. We can just zoom in on it. Quadrant. And then this will be enemy ship map. And we will do m.adjust. And this will be ships. The current sector. And the enemy ship map. That's what we have to use. Okay. That's all the type errors there. Let's see. Probably have a couple more places in some different, slightly different modules to handle. And then we should be back to green. Let's go to simulation. That one is at 206. Update enemy states. Yep. Update enemy state. Okay, so for this one, we get the sector and update enemy state. Update enemy trolling. Okay. Well, in order for update, this is going to trickle down a little bit, I feel, but let's just do it, and then we can clean it up later in a refactoring pass. So in order to get sector to pass in to get the alive enemies, of course, we have to get that from the quadrant. So that's current sector. And we'll get quadrant. Yeah, this mutates in the state, so I wonder if this is gonna actually think it'll work. Hopefully it'll work. Okay, so sector, we get sector, quadrant, and current sector. It's like this pattern is repeated a lot in the changes that we're making. That's probably going to be Q, so we might have to import that. It was already imported. Stop. Quadrant as Q. Okay. So then update enemy state. Gets the enemy state, checks if it's patrolling or fighting, and just goes along, passing the E there. So then we get the player ship, and when in range, we're just interrogating the player ship for that. We zoom in on the game state sector here, and we update the enemy's array. So we have to use our pattern, same pattern again, I think, here, to update the enemy's array in the map of the quadrant. So we're going to use the game state sector. And we're going to zoom in on the game state quadrant. And quadrant enemy ships. This is going to be the enemy ship map. Well, that's going to be adjust. We can bring enemies back into scope here at the current sector of the enemy ship map. So we just need data map. Okay, that seemed to do okay. I think that's obscuring another place where we have to do this again, but that's okay. Let's fix this one too. So sector again. This is current sector. We know that. And in order to get the sector, get it from the quadrant. Try and use the same structure of transformations consistently. This is a thing I've done a fair bit before when doing these kinds of changes to a Haskell program. If you notice a pattern, don't try and abstract it. Don't try to like compress it down right away. Do it the kind of annoying way first, but you do it consistently so that it makes those transformations at the later step when you want to do that refactoring pass just a lot more straightforward, because you can just kind of grep around for the pattern and nail all the areas that you need to nail. So we usually do quadrant first, at least in this file. Hopefully I've been using it consistently throughout the evening. Game state quadrant. And that's going to be q.get sector. Yeah, and that was obscuring this one too, so we're going to do that as well here. I don't think we need to use it there necessarily. We just need the current sector. And then we need to zoom in on the quadrant. And q.quadrant enemy ships. This becomes enemy ship map. This becomes adjust. And we bring enemies back in scope like this as the function. To adjust, we give the current sector coord and the enemy ship map. Current sector, sorry. Okay, and then we got stars and stuff. What is this all about? No instance for has stars. Right, so the lenses here are focusing in on a record that's not there anymore. I wonder if we can define some lenses that actually like zoom in on, like through the quadrant to the current sector. That would be pretty sweet. But in order to do this, now we just need the star map because we're just checking against it, right? So a different way we can get that. Get the current sector. And quadrant. And then we can get stars becomes pure function, isn't it? I'm going to import that operator though. We get the quadrant star map. Do it like this. We go bang and current sector. Just have to import that operator. I think that works. Okay, collisions with enemies. We're not updating the enemies here, right? We're just reading them. So I think we'll have a similar pattern. Quadrant, enemy, ship map. Quadrant, q.quadrant, enemy ships. And that will be quadrant, enemy ship map. We got to bring in the current sector coordinate. No problem. Just forgot that sector over there. Dang. Okay, one more. And similar pattern for collisions. So quadrant station map. Q.quadrant station map. Stations. Yeah, and then current sector. Will be use game state sector. And then we can let stations equal the quadrant station map indexed by the current sector. And that should go that way. Okay. And one more time for docking. Okay, so then we need to get the quadrant station map. Sector, the quadrant station map. Game state quadrant. Q quadrant stations. Burn sector. And we can replace this equation with quadrant station map indexed by the current sector. We don't have any binding issues, but we might, so we'll put that in parentheses. We don't need fmap over that. Well, that's a pure function now, so we don't need the bind. And some duplication that it's trying to warn us about. Let's see. Yeah, so it's just trying to helpfully warn us about some duplication we've got going on in this file, which is good. So I think we should have a helper function for that. Call it get current sector. And it'll be a state, game state to sector. It's about 216 right here, something like this. We'll just encapsulate that pattern here. Okay, and so then we can go back to that. Right, and we can replace this whole thing with sector, get current sector. Dope. Is there anywhere else we can use that at the moment? This one's kind of different. It's a little bit different because we use it in the adjust expression here. Okay, so we can use it here. That should be good. Just some test update code. So we'll continue with this and then we'll fix the tests. And we should be good to go because we're running a little low on time this week. We're almost done here today, my friends. I think that might be all the places we can use it for now. Yeah, the others I think we'll clean up in another pass. So that's just getting out individual parts of the quadrant. It's adjusting parts of the current quadrant data. Okay. So let's get the test module passing again. And then just test that the game still works the way we expect it, and then we should be good to go. Hopefully everything is just fine. So this isn't passing over because of this sector setup stuff. We explicitly set up a lot of state here in this test module. Okay, so our first one is on 284, so let's just jump over there. Okay, so our initial state here, game state sector should be 0, 0. And then we need a game state quadrant. We need the init quadrant. And I think in this case, I'm going to pull that up there and just comment it out for a second. I think the data there is the same. Well, we changed it slightly because we changed the hull amount. This one's specifically testing that. Okay, so it's a little bit different. So we want it in a quadrant where, or such that the quadrant enemy ships is something like that. Do we have a singleton function in map? I believe we do. So we can do map singleton 0, 0 and this cat here. Let's change it to M and be a little bit consistent here. And then we have to import data.map. Qualified. And our package needs containers as well for the test module, the dependencies there. Now, quadrant enemy ships is not in scope because we don't have quadrants in scope, do we? Okay, good, good, good. Okay, that's just a lot of setup code that needs to be fixed. But we are so close. Okay, I just want to know that we're on the right path first. I'm just going to build it without the tests and try it out. Alright, we should be able to shields up. We should be able to move at 8-2. We're still moving. We took a little damage. If we try firing our phasers, we should get that warning and take another more damage. We do. We get shields down. We can fire phasers. Destroy the ship. Okay, we only have like 18 energy left. We can dock, recharge. Okay, so far so good. Looks like everything's working just fine with our approach here. And up to implementing our quadrant map. So, sick. I'm gonna commit this as is with the tests broken, just because it's on our little test branch. There's quite a lot of stuff. It's a big change, but it's all good. So we stage that. Add quadrant. A quadrant represents a region of space as a map of sectors. It should be 8 by 8 or so. Mostly not implemented yet. Just the basics implemented so far. Okay, so I'll push up the quadrant branch. And so if this is your first time tuning in, thank you for watching and hanging out with me. All the codes you've seen tonight for this project, LambdaTrek is up on my GitHub here. So there's our quadrant branch. We're doing our work on this whole quadrant idea and this representation of how to do all this quadrant-y stuff. So next week, once we get the tests working again, we can actually implement the UI for our warp menu. And yeah, talk about jumping to other, or viewing the quadrant map and then jumping to and implementing our warp command so we can jump to other sectors. And yeah, then the game world will expand out. This is kind of my favorite way of approaching roguelike development. You kind of just start with one room. Don't try to implement the dungeon generator at first, even though it's like the most fun part. And then just get all like the basic interactions going, and then start building out the world and making it bigger from there. So that's what we're doing. We're getting there, and that's what we'll work on next week. So I'm on the GitHubs. You can follow me there. You can follow this project, Forkstar, whatever you want. All good. I'm also on the social media on well, if you can call it that, on Mastodon, at the types.pl server, also as Agent Ultra. Follow me there. If you go to the link above, that's, I think it's like declarative.tv, you know. There's a link to a Discord server where we have a channel for this stream here where you can like chat between streams and talk about whatever. And if you're on my YouTube and stuff, and even here on Twitch, you know, press those buttons, subscribe, notify, like things, whatever, and all that stuff. If you like what you saw this week and want to get notified of more. So that's all I got for this week. Thanks again. May your monads always be free and your types always check. And we'll see you maybe next week around the same time. I usually start these streams Tuesday evenings, 10 after 8 in the Eastern Standard Time Zone. Farewell. Happy hacking out there. See ya.